Thank you for being here very early in the morning on the last day of the conference. My name is Kay Morano, and I work with the Home Ownership Unit of Commerce. And I am very happy this morning to be able to be the moderator for this session and listen to what we're going to learn about AI. But I do want to remind you all, before I tell you who's speaking to us, to use the Whova app for any questions and things like that. And if you're looking at the actual agenda and you click on this session, it lets you into the comments and the Q&A section. So please join me in welcoming Phoebe Vallanos.
Good morning, everyone, and thanks for being here so early in the morning. I really appreciate it. So my name is Phoebe Vallanos, and I'm an associate professor of industrial and systems engineering and computer science at the University of Southern California. At USC, I actually also co-direct the Center for AI in Society. This is an interdisciplinary research initiative between the schools of engineering and social work. So basically our goal is to advance knowledge in AI to address important societal problems. And homelessness is actually one of the biggest issues we're trying to grapple with and solve using AI. So just as a bit of a background, I probably come from background very different than the rest of the people, or the majority of the people at this conference. I'm actually a computer scientist by training. I did my PhD in Imperial College in computer science, really focusing on advancing algorithms, mathematical models, computer science to tackle, to address decision-making problems. So the main question I try to answer in my PhD is how can we actually use data to make good decisions using computing. So when I talk about decisions, today I'm going to be talking about policy making, but it could be any kind of decisions, like how to get from point A to point B using Google Maps and things like that. But really my work was very methodological and theoretical. And in my mind, it was like, well, I'm going to have these nice algorithms and these nice models, and then people can figure out how to use them to do nice things. But then when I joined USC, I kind of started thinking, well, why let other people find ways to use the tools that I create? How about I do it myself? And how about I do it to solve problems that I care about and I think are worth looking at and solving? And that's when I started partnering with organizations, trying to listen, well, what are the problems they're faced with, and what kind of AI do they need in order to help solve the problems they have? And this is a nice, for me, it's a very rewarding way of working in that, I work on problems that I think are important and that, where I really think I can help move the needle, but also it's challenging methodologically, so it's also rewarding for me from a research perspective to do these advances in AI, basically. So with all that said, when I joined USC, I was really fortunate to meet Professor Eric Rice, who's actually an expert on homelessness, and with whom we started working. That's now probably 8 years ago. And so we reached out actually to LAHSA, the Los Angeles Homeless Services Authority, to see, well, is there anything we could do to help address the problems they're faced with? And actually everything they told us about is exactly the kind of problems that in my research I'm interested in looking at. So problems where data may be scarce, where data is biased or noisy. Can we still make use of this data in order to make good decisions? And in this case, the problem that they needed help with is, well, there's severe inequities in housing, in homelessness in particular in LA. What can we do in order to help mitigate them? How can we make use of very scarce resources? Where I'm coming from here is that most of the tools that we have at our disposal in AI can't actually be used just off the shelf, right? And at the same time, it's really costly to run new models. It's even sometimes costly to use them. You also need actually quite a bit of skill, even to use existing models, and even more so to train new models. And existing AI models work a lot like black boxes. We don't know exactly what they're doing under the hood. And this poses huge issues when we're working in high-stakes settings, such as the ones I'm interested in working with in my work. And at the same time, you probably all have heard of bias creeping into AI models, and this could happen, by the way, whether your data is biased or not. So really, we do need tailored AI models that can circumvent those issues so that we can use them in those high-stakes settings. And so this is what we're trying to do in the Center for AI in Society, is really to advance AI in a direction that it can help support vulnerable communities. So today I'll tell you about one specific problem, right, related to homelessness that we're working to address. So in LA, much like in many cities in Washington state, we have a massive homelessness crisis. So the local housing authority has at its disposal housing resources available to help, 28,600 of them actually. But unfortunately, and these take the form of short or long-term interventions. So something called permanent supportive housing is like indefinite duration, and something called rapid rehousing is a short-term kind of voucher-based intervention. Unfortunately, though, most of these resources are already in use, and meanwhile, every night we have over 75,000 people sleeping on the streets or in shelters. And the situation actually keeps getting worse. The number of people experiencing homelessness keeps growing, and resources can simply not keep up. At the same time, there's actually severe inequities in homelessness. For example, in LA, we have 9% of people who are Black, but 40% of people who are experiencing homelessness that are Black. So really, Black people are disproportionately affected by homelessness, and this is just one of the numbers. I can give you many more statistics that speak to the biases in homelessness. So really, we'd like that as we start thinking about how to give out those resources, we need to keep all these issues in mind, right? Shortage of resources, severe inequities. So how does the current system work? In the current system, when you're in need of a housing resource, you complete this survey that I'm showing on the left. It's called the VISPDAT, the Vulnerability Index Service Prioritization Decision Assistance Tool. It basically asks very personal questions of people with lived experiences, really a pen and paper survey. Depending on how you answer each of the questions, you get a score for that question. All of the scores are then added up together to give your so-called vulnerability score. This vulnerability score is meant to predict sort of adverse outcomes that could happen to you. It's quite correlated with not being able to exit homeless without support. Okay? And then the higher you score, the more likely you are to get one of the more supportive housing resources, this permanent supportive housing that I told you about. If you score in the middle range, you're more likely to get something called rapid rehousing, this shorter term intervention. And if you score on the lower end, you're most likely to get nothing. This is not, people are not tied to this score, so there is some flexibility. In fact, if you look at the data, there's a lot of people scoring low who actually get permanent supportive housing. Vice versa, there's many people who scores high who get nothing, and so on. So our goal with LASA was actually to try and create an AI-driven system that would be less unidimensional. So here, the idea of prioritizing by vulnerability is clearly very nice in some sense, right? We're supporting more those who need it the most. But on the other hand, it doesn't really look at outcomes, right? It doesn't tell us, well, if we implement this policy, who gets what resource, who exits homelessness? Like, it doesn't really think about fairness. It doesn't really think about, are we making good use of our resources in the sense of, are we really giving the resources in a way that we're going to have as many people exit homelessness as possible? So it has some very appealing features. It's kind of easy to understand how it works. It's somewhat transparent, but it really does not look at these outcomes. So we wanted to build something that's a little bit more scientific, more outcome-driven, and perhaps more transparent, because although this does look transparent, perhaps it is not, in a sense that we have many people that look the same that get very different resources, which is perhaps not attractive. And we also have people who score lower get better, quote unquote, resources than people who score higher, which is also something that's hard to justify. And which would be important to justify in a system where we're talking about resources that are needed to satisfy basic needs, right? So this is our goal with LASA, right? So what we did is we sat down and we thought, well, what are the characteristics that a system that allocates such resources should actually have? And the first characteristic is it should be efficient in some way. We should be able to say that we're making good use of our resources. Perhaps, for example, we're maximizing exits from homelessness. You could measure outcomes in different ways. This is one way that we could at least measure in the data exits from homelessness. So efficiency in that sense. The second thing we would like from such a system is that it should be fair. And in particular, it should be fair in a way that is sensitive to these pre-existing inequalities I mentioned earlier. And finally, it should be transparent, such that we can at least justify why someone got a resource over somebody else. But actually building such a system is not easy. And first of all, it requires us to define what is actually fair. Okay? And that's a very complicated question, right? For example, shall we prioritize people who have been waiting the longest? That seems like a reasonable choice. That seems in some sense fair. Shall we prioritize those who are more likely to be taken advantage of if we leave them on the streets? That also seems reasonable. Or perhaps we should prioritize just older people because they're less likely to find the income needed to get housing. Right? So there's many ways of defining fairness that seem very reasonable, and perhaps we want a combination of them. But based on our conversations with policymakers and stakeholders, it seems that when we talk about fairness in this context, really what we're talking about is fairness with respect to protected characteristics. So things like age, race, gender, and so on. And so what we did is we actually went and saw, well, how do policymakers and stakeholders actually measure how fair the system is? Maybe this can give us a sense of how we would like to design the system, right? And so the first thing that they mentioned caring about is actually who gets housing. What we call, like in mathematical lingo, statistical parity in allocation. So this notion of fairness requires that all protected groups should get housing at equal rates. So that, for example, black people should get housing at the same rate as white people. This is a very natural and kind of simple notion of fairness that we can probably all get on board with. The second thing stakeholders seem to care about is something we call mathematically statistical parity in outcomes. Now this this is looking at outcomes. It requires that all protected groups should exit homelessness at the same rate. So that, for example, no matter if you're white or black, you should have the same chance of exiting homelessness. So ideally, what we would like to do is to have both notions at once. So if I talk like from an AI perspective at what I would like to do is to design a system. What is a system? It's a way of deciding when someone arrives in the system which kind of resource they should receive. Okay, taking into account the fact that there's only so many resources. I can't have more resources that exist. So what I'm looking for is really such a policy, right? That's going to help me decide who gets what. That satisfies both of these notions, meaning a policy that's going to be in the intersection of these two disks. Unfortunately, though, it turns out that it is typically not possible to have both notions at the same time. And this is something we can show like mathematically. And so this raises a number of moral dilemmas, right? So the first one is whether we're OK to depart from statistical parity in allocation, this allocative fairness that looks at who gets housing, to actually get closer to just if we're willing to just step away from that, right? And then if we say that we are willing to step away from this notion of fairness, that's quite traditional, a natural like second moral dilemma is then, well, how far are we actually willing to go? And there's actually a spectrum. So the first thing we could do is something similar to what is done in LA right now, this prioritization by vulnerability score that I mentioned. So remember, vulnerability score is about, it helps us get a sense of how likely it is for someone to so-called self-resolve, meaning to exit homelessness if we don't give them any resources. Right? If we start prioritizing based on how difficult it is for people to self-resolve, we can get closer to outcome parity without deviating too much from allocation parity. Why is that? Intuitively, well, because we're helping those who need it the most, right? So we're kind of helping equalize things in terms of outcomes. And why is it different than parity in allocation? It's different because for example, if black people are more vulnerable than white people, then this rule would allow us to give them more resources, right? However, prioritizing by vulnerability, like is done in LA, is not necessarily enough to get to outcome parity. We can get a bit closer by using a bit more information, namely how much each type of housing resource helps each individual, okay? And this, again, is akin to giving people resources commensurate to their needs, right? If you are in a bad situation to begin with and you need a lot of help to, and resources don't help you much as a group, then maybe I want to put more resources to that group to make sure they have better outcomes, okay? But again, and perhaps counterintuitively, using these two types of information does not help us close the gap entirely. But still nothing controversial so far. Where it gets controversial is what happens if we want to get even closer to outcome parity. If we want to get even closer to outcome parity, we need to use more information, like unprotected characteristics. So information like where people sleep at night, information on recent hospital stays, and so on. And while this may seem not controversial, we have found in our research that actually it only helps you get closer to outcome parity to the extent that these unprotected characteristics are predictive of the protected ones. So to the extent that they help you predict race, gender, and so on. And in fact, if we want to get as close as possible to outcome parity, we may have to use those protected characteristics. This, of course, poses huge ethical and practical dilemmas because we all know that making housing allocation decisions based on race is not allowed. And in fact, even if it were allowed, it's really difficult to ensure that policies that use those protected characteristics are not discriminatory, even if they are well-intended. And so these findings raise huge moral dilemmas and huge practical difficulties in having a system like the one we are envisioning, right? So we said we want to maximize efficiency, we want the system to be fair, we want it to be transparent, but actually all these things push the system in different directions. The more transparent you want the system, in some sense the more simple you want it to be so that you can explain it, the less efficient it's going to be, the less good use of the resources you're going to be able to make. Similarly, if you have a system that's very transparent, then it's going to be really hard to make it fair. And so we have all these different things that are pushing the system in different directions. So the question we're trying to address here, so now I've given you the background. The question is, well, can we actually design a system that is like we want it? Okay? There's two challenges in doing this. The first one is understanding, well, what is it that we want this system to be doing, right? We said fair, efficient, transparent, but what do all these things actually mean, right? There's all these different notions of fairness. Shall we use protected characteristics? Do we want to be fair in allocation, fair in outcomes? Do we want a bit of both, maybe, something in between? How much more do I care about efficiency than I care about fairness? How much more do I care about transparency than I care about fairness? So the first step in designing such a system is learning what it is that we want this system to be doing. And what we propose to do in our research is to use AI to actually learn those preferences. And then the second step, once I know what you want the system to be doing, is actually design a system that does what we want. And clearly, this is quite difficult because, right, we have all these people on the ground, right, making decisions about who should get what kind of housing resource. And these decisions impact all these outcomes we talked about, right? They impact how good use we make of our resources. They impact how fair our system is and in what ways it is fair and so on. So can we, in some disciplined way, first of all, figure out if we implement a policy, what the resulting outcomes will work, what these numbers will look like, what these statistics will look like. But can we also actually optimize over these policies? And so how can we use AI to decide what is the best policy, and in particular, design a policy that will align with those preferences that we learned and be fair in the ways that we want? Okay, so these are the two steps. So I'm going to start talking about the first step first, which is about learning preferences. And then I'll tell you how we can actually learn a policy that will align with those preferences. Okay? So our idea to learn the preferences is actually based on something that has been around in AI for a while, which is called preference elicitation. So you guys may have heard about it from the self-driving car business. So you know, when you have a self-driving car on the road, it's often faced with different moral dilemmas, right? Like, I don't have time to brake. Should I hit the people crossing the road, or should I swerve and perhaps injure some of the passengers? And so self-driving cars need to make decisions of this type all the time. And one way of learning their preference, learning how we want the self-driving cars to behave, is to actually put them in front of scenarios where they have to make these hard decisions. So what we propose to do is something similar. We're going to have our stakeholders, policymakers, people with lived experience, and so on, make decisions between scenarios that are difficult. I'm showing here a kind of caricature scenario just to exaggerate what our examples look like, but you can imagine these getting quite intricate. So let's see. In this example, we're showing two policies. On the left is a policy that is quite efficient. We have a lot of exits from homelessness overall, but it's quite unfair in the sense that we have far more exits from homelessness for white people than for other groups. On the other hand, on the right, we have a policy that's extremely fair, but it's a lot less efficient. Okay? So by having you pick which one you prefer, I can learn something about, how you mean fairness, whether you care about efficiency more than fairness, and so on. And now you can imagine that by asking more and more similar scenarios and asking, comparing policies that are more and more similar to one another, I can really start narrowing down what your preferences are, okay? And so what we did is we actually created an algorithm that selects optimally, in the best possible way for you, what pairwise comparisons to ask you so that we can learn your preferences. And you may ask, well, is that really relevant? Well, actually it is, because I can't ask you like 1 million such comparisons, right? You would probably get tired and not very interested anymore. So with just very few comparisons, like 7 to 10 maybe, really get to the bottom of what you'd like this policy to actually be doing. Okay? This is actually available online, and you can try it out in your own time. I can show you a little bit what this looks like. So we start with just a bit of background on homelessness, just so people become familiar with the underlying biases. In homelessness, become aware of the problem, of the issue of resource scarcity, and so on. We introduce them to the various notions of transparency, fairness, and efficiency. We tell them a little bit about these inequities by age, by race, and by gender. And then they can start the questionnaire. Throughout the questionnaire, we have one policy on the left, one policy on the right, and as you scroll, you can see the different characteristics of the policies, compare them item by item in terms of these measures of fairness and efficiency, and pick at the very end which policy you prefer, or if you're indifferent between these two policies. Depending on how you answer, the AI will adapt the next question that it picks, so it's really an adaptive questionnaire personalized to you. And at the end, you submit your selection for each policy. You answer 10 questions of this type. And our goal is to ask the 10 questions in the best way possible to learn your preferences as quickly as possible. And by the way, this could be adapted to a variety of domains. In case you're working in a different area, you're wanting to use AI, but you need to understand the preferences of your clients. In order to do that, such an algorithm could use, or this algorithm could be used. We evaluated this algorithm on something called Amazon Mechanical Turk. So actually, if you go on this interface, you would go yourself through this trial. How we evaluated it is that when you come into the system, you're either assigned to the top or bottom path. In the top path, you first answer questions according to our algorithm. Then you get a memory wiping question so that you reset your brain, kind of. And then you get 10 questions asked randomly. So policies are picked at random. This is what works best based on previous knowledge. And in the bottom, we kind of flip. We first ask the random questions, and then the questions selected by our algorithm. And at the very end, we want to see, well, what worked best? The algorithm or this random question selection? We found that actually, and so how we do that is we post the recommendation of our algorithm and the recommendation from the random question asking, and ask the user to select which one they prefer. As it turns out, they preferred the recommendation made by our algorithm 2.4 times more often than random, and this was significant difference, actually. The kind of policies that people act, so I don't know if you're familiar with Amazon Mechanical Turk. So Amazon Mechanical Turk is a service provided by Amazon where you can have real people do things for you. So we basically had, and you pay them to do that. So we paid real people to actually go through this process for us. That's how I came up with the 2.4 times number. This is how often actually these real people said they prefer the recommendation we gave over the other approach. And this is just the policy that in the end most people seem to prefer. On the left, I have the characteristics of the people who filled in the survey. People can choose which jobs they take on Amazon Mechanical Turk. So you see that actually most of the people who did our survey knew someone who had experienced homelessness. So it could be either themselves or someone they know. And most were white, male. This is quite typical for Amazon Mechanical Turk. Amazon Mechanical Turk is not a random draw from the population. And the kind of policy they preferred is one that is actually quite efficient. It was the one that had the most exits from homelessness. It had high exits from homelessness for transgender people and for females. And it had the highest worst case across races in terms of outcomes. So it had some notions of fairness in it. Okay, so we see we can learn preferences. Good. So now how do we use those preferences to design a policy that's going to align with them? So again, remember, what do I mean by policy here? It's a mapping, it's a rule that will tell me when someone comes in, based on their characteristics, which resource should they receive? Should they receive this permanent supportive housing? Should they receive rapid rehousing, or should they get nothing? And ideally, everyone should get permanent supportive housing. The reality is that there's just not enough resources, and it doesn't look that like resources are increasing at a rate high enough to have enough resources for everyone. So we have this difficult problem, right? What is the challenge here? The challenge is that the data we have access to is not randomized controlled trial data. You may have heard this term during the COVID pandemic, right? You heard that we're doing randomized controlled trials for vaccines. What does this mean? It means we take people at random in the population and we treat them or not treat them at random with the vaccine, right? And then we see what happens. We can't do this here, first of all, because it would be unethical to withdraw resources from people who need them, but also it takes a lot of time. We have years and years of data at our disposal that we would have to just throw away, and then do again years and years of these like randomized trial to see, well, which resources help people, right? So for practical and ethical reasons, we cannot do these randomized trials here. All we have access to is what is called observational data. This would be the kind of data you would have in the context of the vaccine if you didn't do any randomized trial and you just let people decide if they want to go do the vaccine or not. Okay? So what does our data look like? We had people who showed into the system. They answered the survey, and we have all their answers to this survey. And we also have more generally data from the so-called homeless management information system that gives their personal characteristics. And then we have which resource they have actually received, information on which resource they have actually received. Okay? And then we can see from getting that, if what happened to them after they got that resource. Did they actually exit homelessness? Did we see them again in the system somewhere? And so on. So many challenges due to this observational nature of the data, but also many challenges related to bias in the data, right? This is self-reported data. People may not feel entirely comfortable answering these questions, right? They're actually quite personal, some of them. They ask about history of drug use. They ask information about people taking advantage of them. They're really, really very personal. So people may just not be comfortable answering them. What we're able to show is that we can actually compute from the data the provably best policy, what we call like the optimal policy. What does this mean? It means that among all policies that are fair in the ways that we want, there is no policy that is more efficient. So it makes the best possible use of the resources. And we can compute this directly from the data. Our policy is actually also quite transparent in the following way. When someone comes into the system, we will tell them immediately which resource they will get and an estimate for when they'll be able to get them. So basically, when they come in, they join one of these three queues, either for permanent supportive housing, for rapid rehousing, or no, and they know for sure that they will get that resource. This is very different than what's happening currently, right? And also, sorry, just to add one more thing, also in this system, people who have the same characteristics will get the same thing. There is no way that you have the same characteristic as someone and you get something else. So all these are actually very attractive when we're talking about resources to satisfy basic needs. Okay? And it's very different than what is happening in the current system, where you don't know what you're getting, you don't even know if you're getting something or not, you don't know when you're getting it, and you have the same people that get different things. All right, so in order to make this work, we need to do a bunch of things. The first thing is learn what will happen if we put someone in a particular housing resource. Will they exit homelessness or not? So in order to do this prediction, we use machine learning. We train some of the most modern machine learning models in order to learn from the data these counterfactual outcomes. Okay? These are the results from the machine learning. Each a graph corresponds to a different housing resource. No resource, rapid rehousing, permanent supportive housing. We had two types of permanent supporting housing in LA. On the x-axis, we have the probability that we predict for individuals. And on the y-axis, we have the actual proportion of people who exited homelessness. So ideally, what we would like is all our predictions to lie along this diagonal dotted line. Right? Why is that? I predict that someone has a 60% chance of exiting homelessness. For all the people for whom I predict that they have a 60% chance of exiting, there should be a portion, 60 out of 100 of them, that actually exits in the data. So we can see that everything is pretty well calibrated, meaning that we are along this dotted line. We'd also like our predictions to be in some sense fair. And in what sense? We'd like our algorithms to be equally accurate for people of different races, or with respect to any characteristics that we actually care about, right? And what does that mean, to be equally accurate? It means that the lines are pretty similar no matter which race we look at. Each color in this graph is a different race, and what you can see is that any deviations basically from the line, from this dashed line, dotted line, are very similar across different races. So our machine learning models are actually quite fair. Why is this important? Because let's say that I grossly, for example, overestimate how likely it is for black people to exit homelessness if I don't help them. Then my policy is going to say, well, you don't need to give them many resources, right? They're doing just fine on their own. So it's very important to have this good calibration across all races. Having now learned these counterfactual outcomes, so what would happen to people if I give them resources other than the ones they got in the data, we are ready now to learn our policy. So in this first example, what we did is to try and learn a policy that's actually fair in terms of allocation. I'm considering just two simple settings in my experiment just to illustrate the idea. So on the left, we show the performance of the historical policy in terms of the proportion of people that receive housing by race. In the middle, I show a policy that is the most efficient, but that does not care about fairness. This policy, as you can see, starts giving more resources to white people. It's thinking, actually, this will help me increase exits from homelessness. And on the right, I'm showing the output from our algorithm, where we say that we actually want our policy to be fair in allocation in the following sense. We want to give more resources to the minority groups in order to try and compensate, basically, for historical discrimination. So no matter whether you use the most efficient policy or the policy that's fair in allocation, relative to the historical policy, we can increase exits from homelessness by 3%. This may not sound like a lot if you're not in the homelessness domain, but this is actually massive. You are not changing the amount of resources, right? It's really just by being more strategic about who we give those resources to. And we're able to increase exits from homelessness by 3%, while at the same time having a system that is more fair, in a sense that it's giving more resources to groups that have been traditionally marginalized. Okay? We can also build a system that is fair in its outcomes. So this time my graph is looking at exits from homelessness rather than proportion of people who receive housing. And what we can see is, again, we can have a system that is more efficient while actually still having more exits from homelessness for minority groups than for white people. Okay, so now the question is, well, is it actually are people interested in using AI to address these kind of problems, right? We have seen that there can be really big benefits in using AI. We can have a system that's more efficient. We can have a system that is more fair. What do people think about it? It's somewhat controversial in some way to use AI to make decisions or even recommendations in this context. What we're doing right now is we're conducting interviews with members of the coordinated entry system. The coordinated entry system is what I described earlier, the whole VISP-DAT process, the matching process, and so on. So with the policymakers of the CES, with lead agencies of the CES, and with LASA, Los Angeles Homeless Services Authority staff that interact with these policymakers. So really our goal is to understand from people who are actually doing the work, do these kind of tools help them, right? We, in doing all this work, we met with a subset of people at LASA, and we had this vision, right? What do the people that actually implement those policies think about it? That's what we're trying to learn. We're also starting to work with different agencies in different areas across the US. We recently received a grant from the National Alliance to End Homelessness to conduct similar research in Missouri. And we're now starting to expand across the US and Canada. So there are risks, right, in using AI. We saw a lot of AI is black boxes, a lot of AI lacks interpretability, a lot of AI is biased. But actually, at the same time, I'm a firm believer that if you do it right, AI can actually have huge benefits to help support those underserved and marginalized communities. And really, I believe that more collaborations between computer scientists, between engineers, and social scientists and community organizations should happen to help address those problems. We don't want to be just applying existing AI that may suffer from bias, lack of transparency in this context. Instead, we want to create AI tools that don't have these shortcomings and that can really help the most vulnerable and marginalized communities. So with this, I'd like to close by thanking my close collaborators, in particular Eric Rice, with whom I've been collaborating on this work for the last 8 years, and my students who are the brains behind everything and who do all the hard work. All that I presented is my views, not those of LASA, and I want to thank you and open it up to questions if there's time.
Oh, wait a minute. Oh, it came on quickly. We do have one question on the app right now, and then I will come around with the mic if anybody else has additional questions. But how do you measure demographic income as a part of homelessness? In other words, is income the best predictor?
I don't remember mentioning income, actually. One of the predictors of exits from homelessness in our data was how much financial support we give people experiencing homelessness. So as part of these PSH and RRH intervention, there is some financial support that comes in particular with RRH. You receive financial support to pay for rent. And depending on how much you receive, this is a predictor of whether you're likely to exit more or less likely to exit homelessness or not. But maybe the question is referring to something else that I'm not thinking about. Did I mention something related to income that I'm not thinking about right now?
No, you didn't, but that's a factor of it, because either you get housing, you get income, or you get support.
Sure.
Racial disparity in income is a big predictor in my mind.
Right. Certainly. Yeah, absolutely.
Anybody else have a question?
Apologies if you might have explained it at the beginning, but what kinds of data sets are you using in your AI model?
Yeah, very good. So here we have 3 data sets that we're using. The first one is this data set from the Vulnerability Index and Service Prioritization and Decision Assistance tool, which is this survey. One second. So this survey is a 3-page questionnaire that is self-reported information from people experiencing homelessness. The way the questions were created is like way before my time. They created questions that it's social scientists that created these questions that they believe were associated with being more vulnerable, loosely defined. Vulnerability here meaning that you're more likely to experience adverse outcomes if you're on the street, that you're less likely to find housing on your own, and things like that. The second data set is information from the Homeless Management Information System. This is information on your personal characteristics, personal characteristics of the clients that came in. These are any contact people had with the system, information about their protected characteristics like age, race, gender, and so on. It's in total, we had hundreds and hundreds of columns in this data. And the third data set was something called the Resource Management System that has information about the different types of resources, when they became occupied, when they were vacated, and so on and so forth. Does that answer your question?
So it seemed like one of the goals of the system that you designed was to maximize homelessness exiting. How did you model, or did you model it so that the system didn't just kind of find lost causes and just say no resources? Because obviously if maximizing exiting homelessness is the goal, you give the people that need the least the most.
Yeah,
and then,
that's a good point.
Yeah.
Yeah, absolutely. So the reason we picked this outcome, first of all, is that it's the only one that we could measure with just the HMIS data, just the Homeless Management Information System data. In principle, you could use different outcomes provided you connect this data with county-level data. So then you could have more sophisticated and perhaps more interesting outcomes, like things related to health or adverse outcomes, like deaths and things like that. But your question remains even if you do that. In order to avoid what you're saying, you have the fairness requirements that come in. So for example, you could postulate in your AI system, much like I postulated that I want the system to be fair in X or Z way. Here I talked about fairness in allocation and fairness in outcomes. You could exactly postulate that, no, I want my system to be fair in a way that it does give resources in priority to those who are most at risk, where you define risk in one way or another, for example, these adverse outcomes that I mentioned. Again, we didn't do it because we couldn't link to those data sets, but you could do it in the same way that I've introduced those fairness constraints. Yeah, but that's a great point, actually, very interesting question.
The charts that you showed at the end were mostly focused on race, ethnicity, differences in outcomes. And I'm wondering, with the data that you have through the survey, could you do this kind of parity in outcomes type of methodology for other characteristics like, exposed to violence in the home, or things that are non-race ethnicity but could actually be highly correlated with that and actually more problematic than race ethnicity itself?
Absolutely. So you tell the algorithm, I want it to be fair in XYZ way with respect to XYZ characteristics. And in fact, the characteristics could also be like intersectional. So you could say black women or black women exposed to violence. Everything would work in the same way. What I can think of as a challenge as you start to talking about groups that are smaller is that the smaller the group, the less reliable the predictions that you make. And therefore, the less likely you are to be able to impose those fairness requirements. If the group is somewhat large, then you're able to do that. Yes?
Testing. Hello, thank you for the presentation. My questions are mainly about the kind of implementing this.
Yeah.
So let's say one of our organizations is interested in pursuing this path. Should we coordinate with our local universities to try and get a program? Are there consultants who can now come on and do this? If so, like what's the expected project timeline for something you demonstrated here, and what are the expected costs to our elected officials? Thank you.
Great question. So first of all, I would say for anything related, you can reach out to me or to our coordinator at the Center for AI in Society, and we'll be happy to help in the right way. What you describe is a range of services. So if all you want is, you have exactly this problem, okay? You are in an agency that wants to decide how to allocate housing to people experiencing homelessness, then in principle, it should be just a question of applying our tools to your data. So there would need to be a bit of a time for us to understand, what's your data like, because sometimes people will say it's the same data, but actually it's super messy, or there's not enough data, or things like that. If it's good data, then we can just apply it and run with it, and that should be very quick. If it's more complicated, for example, let's say you have very, very little data. It could be that we need to develop slightly new tools, and then it would be like perhaps a new project, depending on how little data we're talking about. Or perhaps it should be a question of adapting what we're doing to make sure we can still make reliable decisions, even if you have little data. Let's say you have a completely different problem, but that sounds like it's similar. Few resources, allocation. It would take maybe a bit more time than in the first case for us to get acquainted with the problem you're talking about, but then we'd be happy to work together to kind of adapt what we're doing. It could be that you have something totally different. It doesn't have to do with resource allocation. It's maybe a prediction task. Maybe you still want to make some decisions, but they're not resource allocation decisions. You still want to make it with fairness in mind. That could be like a slightly longer project, but that we would still be willing to take on. I'm not sure where you lie on this spectrum. I could give you more detailed answer if you want to tell me, or we can also take it offline. Okay. So in general, we're open to collaborating with organizations that care about similar issues that we do. Some projects could be a little bit more on the applied side because we care even about just the impact of our work. Some could be more on the researchy side in the sense that there is no tool and we need to create a tool in order to solve your problem. But we do the whole spectrum, basically. Sorry.
Hi. I might have misunderstood this part, but the part where you had the Amazon testing and it was all white males kind of doing it to do the survey. Is there would you use something different in reality? Like, were you doing that just as the exercise to have people fill it out for you, or would you normally use a more diverse group to actually set those preferences? Very
good. So this was just like a test to see, does our algorithm work? And this is the cheapest way to test it. We can actually, our goal ultimately is to do it with people at LASA. So the people that are actually making the decisions. We haven't done that yet. We're now working on this like interviewing that I told you about, and the next step would be to actually have them go through the process, and they're the ones making the decisions. We really want to know what it is that they want. I just didn't want to waste their time if it's something that seems like it works on simulation, but when I try it on real people, it's not working. That's why we did this Amazon Mechanical Turk test first. Yeah, and I don't have reason to believe that it would work differently on this group of people versus another. Yeah.
Hi, thanks again. Have you kind of taken this data, or could you, to look at how to expand the resources? I mean, you're looking at like, kind of acknowledging their limited resources. What if LA wanted to expand their resources, and looking similarly at like what the cost would be, kind of cost benefit of like expanding which resources and how that would cost?
Absolutely, that's a fantastic question. It's in my goals for the future. You can absolutely use exactly the modeling techniques and the approaches we've used to precisely answer that question. If I had like X more dollars, how should I spend them? Should I build more PSH? Should I build more RRH? And what? How much of each in order to make the best, to have the most benefit with this amount of funds. Absolutely, yeah, very, very nice question.
Other questions? Okay, I think we're done. Phoebe, thank you so much for the information.
Thank you all for coming, and thanks for the nice questions. Yeah.